In chemistry, we often want to talk about the density of a material. And in order for us to calculate the density of a material, we need to make measurements in lab. The first measurement that we need to make is the mass of the object. Mass is a measure of the amount of matter that's in an object. The more matter we have, the greater our mass is going to be. The units for mass are grams, and in our lab we use an electronic balance to measure mass. In order for us to calculate density, we also need to know the volume of the object. And volume is a measure of the amount of space that an object occupies. If we're looking at a liquid, we can use a graduated cylinder and measure the volume in terms of milliliters. If we talk about a regular shaped object, we can take the length times the width times the height of the object, and that will give us our volume in cubic centimeters. Or if we have an irregular shaped solid, we can use a method called displacement of water to calculate the volume. And then we'd have milliliters for our units. When we talk about density, density is the relationship between mass and volume, or it's the amount of matter that we find in a given space. So density equals the mass per unit volume, or density equals mass divided by volume. And since our units for mass are grams, and our units for volume are milliliters or cubic centimeters, the units for density are either grams per milliliter or grams per cubic centimeter. Now when we make our volume and mass measurements and we calculate the density, we can take that value and we can compare it to actual values. And in order to do that, we would make a percent error calculation. A percent error calculation tells us how far our experimental value is off from the actual value. And to calculate percent error, we would take the absolute value of the actual minus the experimental, divide it by the actual value, and multiply it by 100. So let's say that our experimental value is exactly the same as our actual value. We would take the actual minus the experimental in our numerator, and that would give us a 0. And 0 divided by any number times 100 gives us 0 for our percent error. And that makes sense because if our experimental error or experimental value and our actual value are the same, then we have no error. And we can use our experimental density calculations to identify what the material is. Every substance has a characteristic density. So the better our experimental values are, the easier it'll be for us to identify the substance that makes up a material. Now in labs, we're going to comment on the accuracy and the precision of the data that we collect. Accuracy is how close a measurement is to the actual value. In other words, how close are we to the right answer? And precision is how close a set of measurements are to each other, or how reproducible our results are, or how consistent we are. So if we think about throwing darts at a dartboard, and let's say that we throw 10 darts, and the darts are all over the dartboard, and none of them hit the bullseye. That would mean that we are not precise and we're not accurate with the way we're throwing those darts. But let's say we throw those 10 darts again, and this time we hit exactly the same place on the dartboard, but we don't hit the bullseye. That means we're precise at the way that we're throwing those darts. We're throwing them the same way every time, but we're not throwing them right every time. And if we were to throw those 10 darts and every time hit the bullseye, we're precise and accurate. And in lab, we want to aim towards being as precise and accurate with our measurements as possible.